Hello and welcome to Frost Astrophotography. This is going to be the second project since I upgraded to the monochrome world using the ASI294MM Pro camera and the 7-position electronic filter wheel with the LRGB and SHO filters. I wanted to do something special and extra as my second project, since the first one was merely a short test of the camera. I decided to go to the Rosette Nebula because that is visible in the night sky right now for me here in the northern part of Sweden. And I also wanted to collect a good decent amount of data to make a really good image. I ended up gathering data on this target across 4 different nights and ended up with a total of almost 20 hours of SH&O data after removing a fair good amount of bad frames, I would say. I usually use the website Telescopius to frame my target, and what you do is that you search for the object that you want. In my case, I want the Rosette Nebula, and then you just enter your specifications, your telescope and your camera, and then you just position the field of view exactly the way you want it. And then if you look at the coordinates, the RA and DEC, you just make a note of those and type them into your acquisition software of choice. In Astrophotography tool, you click on the Gear tab and you go to Objects and you go to Custom, and I have typed in my Rosette Nebula Coldwell 49 and the RA and DEC numbers from Telescopius to get exactly the framing that I want. I select that and I click on the Go To, and hopefully my mount will slew over to the Rosette Nebula. Checking my guide scope to see what's happening. It's moving, and I can see that this is the center, so I'm in the right place at least. So I switch back, and I can see it is slew. It's finished slewing. So I will take a snapshot. I think 7 seconds I have by default. I'm also using the HA filter. You can already see the nebula here in these short 7 seconds, but it's not completely centered. So what I will do is I will go to Point Craft. I will select my object again. I will click on the Solve button to do a plate solve, and it will find my location. I will then click on Sync, and I will use the Go to ++ feature over here. That will center the object. Do you see it will move this up to here if everything goes right. Just like that, and then it will do another plate solving. And it didn't need to move anything more. Now it's settling. We can check on the guiding. I don't have my scope exactly lined up, but close enough. And it's finished. And now I can, just to verify that I'm at the Rosette Nebula, I can take a 30-second exposure. Hopefully that will reveal some more information about this nebula. The next thing I'll do then is to make I can't do it right now because I'm shooting an image, but I will make a new light plan, and then I will plan my different filters for the evening, and then it will execute those by itself. So here we can see 30 seconds on the Rosette Nebula using the HA filter. So now I will program my exposures, and I will come back later to show you the processing. Welcome over to PixInsight. This project has been rewarding, but it proved to be rather difficult when it comes to the amount of work you have to put in. I've gathered a total of 275 light frames. That is around 23 hours, I think. After calibration, I decided to use about 235 frames because there were a few frames that had some issues with the stars, and the always occurring clouds interfered with some frames as well. So the total amount that I used ended up being almost 20 hours. I think it was 19.6 hours or something like that. In total, I have taken somewhere around 750 to 1000 calibration frames for this project to accompany my 275 light frames at 5 minutes each. What you see here on the screen is the results of the stacked and processed in a linear state the light frames for the three filters, the H alpha, the oxygen 3, and the sulfur 2 frames. When processing a monochrome image taken with these three narrowband filters, there are of course a lot of steps. The first stage is the linear stage before the image is permanently stretched. And the second stage is the non-linear stage. And in that stage, you do some more processing. You also combine the three filters into a single color image. So in the first linear processing of this image, I ended up with an H alpha looking something like this compared to this original one. And I ended up with an oxygen 3 image looking like this. And I ended up with a sulfur 2 image looking like this. So the next thing I did was to take the three images and remove the stars. So I have H alpha, oxygen 3 and sulfur 2 images. And I also have the stars separate to be used later. I think it's actually more convenient and easier to process the image without the stars and then include the stars at the end. So I combined the image with the three filters, and that gave me an SHO starless image looking something like this. I of course don't want all the green here, so I removed the green. I also made some adjustments to the color curves that made the blue appear a little bit more intense, and also the orange gold in the outskirts of the nebulosity. I then tried to bring out the details inside the nebula. I also applied some sharpening to further bring out the details. And finally, I ran a process called TGB denoise to remove the noise in the image, to smooth the image out, so to speak. I then adjusted some curves and also made some further adjustments to the color in the image to further enhance the blue representing oxygen 3 in the middle here. The final step was to take this starless image and the stars from my hydrogen alpha frame and integrate those two together to make up the final image. Now there you can of course introduce the stars from whichever image you want. Some want to use all three frames combined to make SHO stars, but I feel that the hydrogen alpha stars are nicer to use because they are also black and white, and I just slightly decreased the intensity, like you can see here. So this is the original stars, and I slightly reduced them. and then combine the two together to get the final image looking something like this. Thank you for watching this video. If you want to see more videos like this, please consider subscribing to this channel and click the notification button so that you don't miss out on any upcoming content. Until the next video, I wish you have some clear skies.